Good morning, everyone. How are we doing? Everyone have a big night? I can tell by the energy, everyone's having a good time. Excellent. For our first talk of this morning, I'm bringing up David and Kevin from X15 Ventures, and they're going to be talking about building cloud-native SecDevOps. Please make them welcome.
That's all right. We'll give him a second. Okay. There we go. Number 16 works. Thank you. So yeah, thanks everybody for coming. It's really good to be here. I've been spending the last 2 years working at X15 Ventures, and we'll go in a minute into what X15 Ventures is. In short, it's the venture capital and venture scaling arm of the Commonwealth Bank. And what I've been able to do there is bring 10 years of experience working for tech companies and consultancies and how we actually do cybersecurity in that environment into a regulated financial services environment and marry those things. So instead of doing everything a really old school way, actually doing it in a modern tech way, but in a way that satisfies the regulator and satisfies internal audit function of the bank, et cetera, et cetera. So you're not really going to learn anything from this presentation about like new and sexy DevSecOps or SecOps, but we're doing what everybody else is doing, but in a way that gets through that regulatory environment. So these are the things that we'll go through today. And I'll start by just giving some background on what X15 is and what our ventures are. So I'm guessing everybody knows CBA, the Commonwealth Bank. They've got a whole bunch of subsidiaries, ASB in New Zealand, Bankwest in WA, etc. One of those subsidiaries is X15. And it's there as a strategic counter to the financial technology startups that are gradually going to eat the bank's lunch and every bank's lunch if nothing is done about it. So X15's been created as a wholly owned subsidiary of the bank, and then X15 itself has a portfolio of ventures that fit into those three categories you see on the screen. The ones that I'm most interested in are we build and we buy. The we invest category is minority investments. So typically 10%, 20%, 30% equity stake in those ventures. And as the head of cybersecurity for X15, I don't really have anything to do with it. Maybe get consulted on due diligence before making an investment. But once you own 20% of a company, besides getting a seat on the board, you don't really have much to do with controlling their day-to-day cybersecurity operations. So those aren't really going to be in scope for today's talk. The ones where we've built it from scratch ourselves or we've acquired it are where they're 100% owned by X15 and therefore by the bank. And so my team operates the entire cybersecurity function for those businesses. So we've got 7 people. The bank has 500 people doing cybersecurity. We've got 7, and we cover all the same domains, everything from red team, blue team, regulatory compliance, etc., just on a very scaled down version. The kind of businesses that we have going from left to right there, Credit Savvy is, you want to know your credit score out of 1,000, you can just get it for free, plug in your personal details and we'll give it to you. Home-In is a home buying concierge, so you're buying a home and there's all these steps you need to do for your finance, for your building and pest, for your conveyancing, and it's just an app where you just follow the bouncing ball and it does it all for you. Cheddar, anyone who reads the media, we just shut down Cheddar. It was a cash back operation, so you buy a pair of sneakers for $100, we give you $10 cash back as part of a shopping deal. That got wound down, as startups do. Unloan, which is probably the most interesting venture from a cybersecurity perspective. We use the analogy that it's like Qantas and Jetstar. CBA is the Qantas home loan, Unloan is the Jetstar home loan. It's the same brand, but it's a different experience and it's way cheaper. They've got the lowest headline rate on a home loan, but you get a much scaled down feature set. There's no bricks and mortar, it's purely online, et cetera, et cetera. And then Kit, which is a next generation children's banking thing. So it's a debit card that you give to your kid, typically aged between about 8 and 14, and then you can load them their pocket money weekly, load them money for chores. The kid gets a gamified app where they can manage their money and save up for things, and you can control categories of spend to make sure they don't just blow it all on Bitcoin or whatever they want to do. Doshi is middleware for hospitality venues. So you've got your Uber Eats, all your different online ordering apps, you've got sales coming off the floor, you've got takeaway orders, you've got your POS system, you've got the people out the back actually cooking, and it's software that interfaces all of those systems together into a unified experience. And the way that most of these things have been built is on a Microsoft platform, but not exclusively. And we'll talk about that in a minute. There is a diverse technology landscape across these ventures. Some of them we've acquired, some of them we've built from scratch. So Microsoft platform is a bit of a common theme. That's the strategic platform. But for example, Doshi, which we acquired, is an AWS shop, and we don't intend to change that. So we have a heterogeneous cloud environment and an even more heterogeneous programming environment. It's not just one stack. We've got a bunch of different frameworks and programming languages in there that we need to be able to handle. And then you've got a really complicated regulatory landscape. And it ranges from, at the top, Unloan, which is basically a banking product. It is a banking product. And it's regulated by an Australian credit license. It's a designated AusTrack service, etc. All the way down to something like Doshi, which has pretty much no regulatory oversight whatsoever. The hospitality industry, there's not really any regulator. So we have a range of requirements that pertain to these different ventures that we then have to implement cybersecurity for. So we can't just, like when I worked for tech companies, you just do whatever is best for the customer. You do whatever is going to be the best for the developers and gets you the most secure product and patches vulnerabilities the fastest. In a regulated financial services environment, that very much takes a back seat to what is APRA hassling you about? What are the auditors hassling you about? And then you have to satisfy them while also actually doing real security over on the side. So the way that most people actually build security in that regulated environment is pretty old school. So security assurance is pen test. You can just pen test everything again and again and again, whether it's software that you build in-house or something you buy from a third party, run it through a pen test cycle, and that will satisfy APRA CPS 234, no problem. But this is expensive, and I view pen test, I was a pen tester for years, there's people in the audience I've worked with in pen testing. It's a sunk cost. You burn 20 grand on a pen test and you get some findings and then you fix them and you're done. There is no enduring value whatsoever to doing a pen test. And 6 months later it's out of date and you just have to do it again and again and again for it to be valuable. So the way that, for example, the bank, I built the product security function within CBA when I was there from 2018 to 2021. We moved how we test software that we build in-house from this blunt pen test instrument to the way that a software company actually does it, so something resembling DevSecOps, where you actually have controls in the build system, you're educating developers, and you have security controls built into the software development lifecycle rather than just pen test at standardized intervals or at major release vehicles. So the banks were already doing that and getting it through the regulator, but I wanted to take it further and do the full DevSecOps thing. So I don't think I necessarily need to sell why you should shift left security to an audience like this, but I'll briefly go over it, which is when you do security testing primarily through things like pen tests, and it's not necessarily a pen test, it could be a bug bounty, it could be other forms of assurance that take place at a point in time. That point in time is typically in something like a waterfall development schedule. So you build a product and then you subject it to this security assurance testing, and then anything that you find, you have to go all the way back to the top of the waterfall to fix it. It's extremely expensive, and as research has shown, the further you get, the important thing in this graph is the red line. The further you get to the right, i.e. along the temporal axis of the graph from when the code was written, the more expensive it is to fix any vulnerability that you found. It's not really controversial. Whether it actually goes up to 640 times or not, I don't know if that's true, but it definitely goes up a lot. So shift left, the terminology is you're shifting left on the x-axis, on the temporal axis of this graph. So we've done this using a variety of approaches. AusCERT2023, I know the AusCERT2023 guys are here, we're using their product for continuous monitoring of the attack surface. This has been able to get us through a lot of regulatory hurdles around vulnerability and patch management. I am completely allergic to using something like Qualys, and it's the last thing I'll ever do. Sorry if anybody's from Qualys. But then you can't not have a vulnerability management control. All these regulators are going to say, how do you know that your systems are patched? So we've been able to use something like that and say, okay, I don't know whether I'm running a Windows server that's got a vulnerable version of Excel installed on it, but I don't care about that. What I care about is that I have an internet exposed server with something that's got a public exploit, and I know I don't have that because of continuous monitoring. There are other products in the market that do similar things. WAFs, DevSecOps, bug bounties. So we're also using BugCrowd for a bug bounty program across all of the products. We've actually got one running right now. Red teaming, and then of course we still do pen tests. So APRA CPS 234, amongst many other things, says thou shalt do a pen test every year as required by the risk of your environment, and if you don't do that, you're never going to pass the regulator. So we still do that, but doing a pen test per system on an annualized basis is actually valuable, rather than having to just do it again and again and again and have this sunk cost with very few findings. So taking these new approaches, I'll drill a little bit into the DevSecOps one in more detail, because that's the shift left. So what we've done, because it's a cloud-native environment, and when I say cloud-native environment, we literally have no infra at all. These end-user laptops, that's it. That's all we own. So everything's in GitHub. This is all basically GitHub Advanced Security, where you've got CodeQL, secret scanning, Dependabot, et cetera, going on in the GitHub Advanced Security environment. And then that's hooked up to the CI/CD system. So we fail builds. If they fail security checks, users have to put things onto a whitelist or an allow list for them to pass if they've failed because of the build. And then once we actually get to the cloud hosting environments, we've got CSPM in both AWS and Azure to ensure that the configuration of that environment at runtime is also secure. So what you get by building this is a pipeline where you say, I don't actually know what they pushed to prod last week, but I know that it had to go through a cycle of security assurance in order to land in prod in the first place. And if you can convince regulators and auditors that because they look at everything through the lens of controls. What's your control for this going to prod? And if you can say there's an entirely automated control pipeline that stops vulnerable stuff going to prod, or stuff in prod being incorrectly configured, it seems to work. And we'll talk more about how I've got it through regulators later. So to give an example, and you won't be able to see this, the resolution is terrible on this image, but this is like a CodeQL finding, and I've used an innocuous one because it's polynomial expansion, denial of service. It was a real vulnerability, but not one that you particularly care about. So we get findings like this, and as you can see, have to resolve it for the branch to merge. And the same with Dependabot. This was a real vulnerable dependency, but we weren't actually exposing the vulnerable use case. And again, you had to resolve it for that build to actually make it into prod. So how did I sell this whole approach? Because the old school approach was you pen test everything all the time, anytime there's a major change. You've got all these other manual controls like a cybersecurity threat and risk assessment, all these point-in-time assessments going on, and that's how you get security assurance of what's in prod. So what I took to the bank's Risk and Operations Committee was this security assurance model, where in the middle you've got a bunch of baseline controls that says, because we have the X15 security team, we bake a bunch of stuff in. So group controls is stuff like, as a CBA employee, I have to do cybersecurity awareness training. I have to get a criminal record check. The X15 security lead is every venture, every company that we own has an assigned security lead. We've got Asset Note and the WAF providing continuous coverage, and every year we pen test every system as part of the BAU program. So that's just baked into everything. And then for each individual venture, you can assess their relative security maturity. And that's done in a number of dimensions that we'll look at in a minute that map to the NIST CSF framework. So you assess their relative maturity in all these dimensions, and then you've got a bunch of optional point-in-time assessments. And the idea of this approach is to minimize point-in-time assessments as much as possible because they're a sunk cost. So what you're able to do is assess the venture security maturity against these criteria, which come from NIST CSF. So I didn't just make it up, but I kind of did. I didn't make up the categories. I did make up the criteria for what level, but that's between you and me. So you can see here the internal processes, the DevSecOps, the training of developers, identity and access management, etc., and different objective criteria for each level. Then you get to, and I can't tell you which ventures they are, but some ventures that we launched, and you get this kind of, what would you call this, like a sector plot or something, where you've got the more it goes out in the pink dimensions, the higher security maturity you have in that dimension. So the one on the left has quite immature security practices within that organization. The one on the right has much more mature security practices, and you can see that by the levels that they've achieved in those different security maturity assessments. However, what you see is the one on the left actually got less point-in-time assessments than the one on the right. And the reason for that is what you lay over the top of all of this is an inherent risk assessment of the venture. So the one on the left is probably going to be doing something in a highly unregulated environment where we don't have a lot of sensitive data or financial transactions, and the one on the right, the opposite. So we can use all of these things to then put together a framework and say, we are going to ship some big new product that does something in a highly regulated financial services environment. Here's a security maturity assessment of what we've baked into the product. Here's a bunch of point-in-time assessments that we think are relevant for it to go live. And then we've got a framework for how you release things. And you also incentivize the people running those ventures to build security maturity, because you say to them, next time you do a major change or a big new feature, we're going to make you do all the same point-in-time assessments at your expense, unless you can grow your maturity further in these dimensions, and therefore we can start to cut out point-in-time assessments for you. So that's kind of on the product delivery side and the DevSecOps side. And I'll hand over to my colleague Kevin, who's our Blue Team SecOps lead, to speak about how we actually operate these things in production.
G'day everyone, my name is Kevin, and like DJ said, I lead the security operations function. So what we are is we provide detection and response services to X15 Core, but also to the benches. Like DJ said, this is more of a bird's eye view than going into the granular details of what we've done. But we'd hope to share our challenges and our approaches as well. So traditionally, SecOps is associated with a lot of cost to set up, mainly because there's operational costs, having it on-prem, but we only have physical devices. We're not hairpinned to a physical network. We don't have VPNs. We leverage the public cloud for our workplace identities, but also our workloads. So even though we benefit from this cloud native and greenfield environment, there were some challenges and requirements that we needed to meet in order to provide these services to the ventures. So let's kind of dig into some of them. So most of our workloads run on Azure and some in AWS. So our solution needed to be multi-tenant and multi-cloud environment. And we only have, at the time, 2 people focusing on SecOps, right? So our solution needed to be deployable, scalable, but also configurable to each of the ventures. And being a multi-tenant environment, some of the existing processes were not really scalable. This led to certain alerts being dealt in isolation, and some were not really tended to on time. So what were our approaches to this? So these are really high level. So we were very intentional about how we collect logs. So our approach was to have a use case or risk-based driven approach. That means collecting only the things that we think are relevant to security. There are trade-offs with that, but there are varying, the ventures vary in different maturity levels, so we were quite comfortable with that. I'll talk more about that as we get on the slide. So what I meant by targeted log collection, so we primarily collect logs that have security value for threat detection, and we split out the ones that are very verbose into a cheaper tier or an archive tier. Depending on what SIEM you got, you might have that ability or capability, but that's our general approach to log collection. And building around existing processes, so our detection content is built around the controls and processes that we know about. That means we produce better detection content. When it hits the analyst, there's actually sufficient context to tell you what has happened. So an example of that, the way we grant resources to our environment is through conditional access policy. This is just a simplified example. But how do you monitor the modification of those policies? In a lot of environments, that might be like a blind spot. There are exclusion groups maybe in that conditional access policy that you might not be aware of. But how does an attacker actually get to that part, right? So it's about identifying the critical attack paths to your environment, and then trying to reproduce whether your existing detection rules pop up, and if not, review those logs and produce those detections. One of the other things that we needed to do is keep overheads low. again, as a team of 2 that are doing SecOps, we approach this with infrastructure as code deployment, and we scale this out using GitHub Actions across multiple tenants. So the solution we came up with is based on the Microsoft Sentinel solution. It's cloud native. I'm not trying to sell Microsoft here. I just walked right into it. But it works for the most part for our requirements, right? And using Azure Biceps, ARM templates, and PowerShell, we're able to, deploy some of the artifacts that are like, connecting for first-party data connectors straight away. And by default, we collect all management plane logs. That means Azure Activity Logs for subscriptions. And I mentioned earlier that we split out different logs based on their value. So I would refer that to the data plane logs, right? Some of them would go into the basic search or an archive tier for on-demand searches. And we also integrate with external data sources like the group's tip and also asset note. It's not really outlined in this diagram, but we build data connectors as well for SaaS applications because our workplace environment, most of our workloads are run in the public cloud, and we don't have any kind of on-prem workloads, right? So often you see ventures using a lot of SaaS apps to, fulfill their requirements. So we mentioned before about multi-tenant management. So what we do is leverage Azure Lighthouse and have a dedicated landing zone to each venture tenant. And this applies even if you're in AWS, right? So we'd have a landing zone in AWS and also in Azure. And we just deploy our resources, dedicated resource for SecOps into those landing zones. I find this is much easier to kind of see costs across the board for different ventures rather than just having some complicated queries to split them out. This is just a zoomed in view of what that looks like. It's an old architecture diagram, but at our current state, we actually split out our automation. So like the logic apps would sit in another resource group because we find ourselves often click opsing that, and we don't really want to have config drifts in our IAC pipeline. For AWS ingestion, we have a dedicated log account in AWS, and the connector is based on an S3 in Sentinel. We pull all those in to a dedicated workspace just for that venture for cloud threat detection and response. Now, this screenshot probably doesn't do it justice for what we've done, but I was locked out from editing the slides any further. But this is just an example of how we do some SOAR capability. So this one is just adding someone into exclusion filter list, but we also use that for automatic enrichment of alerts. And we also built out our custom logic where, because before it would run on an incident level. So for every entity in that incident, if you say block this, it will block every single user, right? But for us, we create a logic app where we can just target a specific user in an incident. Hopefully that gives you a bit of an insight. Kind of rushed it, but I'll hand you over back to DJ around the assessment of environments.
So that's what we built. Then how did we actually get the permission of the bank and the regulators to operate that in production and ultimately to leverage the financial services licenses of the bank? So there's a bunch of different frameworks, assessment criteria that we had to get it through. The first is Essential 8, which I know is not a regulation. It's just an idea about how to do security, but it's one that has a lot of currency. So we did an Essential 8 self-assessment. One of the things that we really struggled with was two things. One was application control and those kind of criteria, because this is an environment where we've prioritized the needs of developers over end users. If you look at a typical bank compute environment, everything's completely locked down because they consider that you don't know how to use a computer and you have access to everybody's banking details. So they want to tightly constrain what you're able to do. They definitely don't want you to do things like download code off the internet and run it. Whereas once you tell a developer, oh, you'd like to install an IDE, sure, file a ticket and someone will assess whether that IDE is appropriate and then push it to your machine maybe next week. That doesn't really work. So we allow people to just download code off the internet and run it because we have to have a productive development environment. So therefore, getting any anywhere up the maturity model on the application control mitigation strategy in Essential 8 is really difficult. The other one is backups. There's a lot of notions in the regular backups mitigation strategies that don't necessarily pertain to a cloud-native environment. They talk a lot about time synchronization of backups, which is very much a notion from the era of data centers and tape backups, that you can have a point in time, 2 a.m. last night, here's all the data. But when your data is federated between different cloud providers, SaaS platforms, etc., they'll all give you the latest version of the data they have, but being able to time synchronize that, I don't know of a solution to that problem. So again, we can't really get past a certain maturity level on that framework. CPS 234 is critical to doing anything with a banking license. One of the big things that we've been able to do to say, we're doing all this cool new stuff, but we haven't completely forgotten about you, is doing the annual BAU pen tests and having the bank's internal pen test team actually do that for us. And what we've found, the last couple of ones that we've done, where we've had ventures where we've subjected them to DevSecOps controls, a bug bounty, we've scanned them with asset note, we've done blah, 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 and blah, and then we get a pen tester who's good and knows the product on it for 2 weeks, and they get 0 findings. So that's been really encouraging, both that our proactive security measures are working, and then to have an artifact that you can give to people and say, and we did your pen test anyway, and it was all fine. We also have the 3 lines of defense model, which people who are in the finance industry might be familiar with. So line 1 is meant to actually, line 1 of a risk or defense or accountability function is meant to actually implement controls. Line 2 is meant to test your controls and validate that they work correctly. And then line 3 is the big bad auditor that comes in and tells you how you screwed everything up. So we are line 1 cybersecurity risk, like me and Kevin, for all of these ventures. Line 2 is a separate team, and then line 3 is the bank's internal audit function. And what we're going through at the moment is an internal audit of cybersecurity across all of these ventures, and the bar that they're holding us to is actually extremely high. It's basically the bar of the rest of the bank. And so far we're kind of getting through that, kind of. The other thing that we've also been through is CAP testing controls audit program, which is where you define each of your controls. So you say, like, we have a DevSecOps control, which is GitHub Advanced Security. And we have a pen test control, which is we pen test stuff every year. And we have a SecOps control, which is Sentinel. And then each of those controls gets assessed for its design effectiveness and its operating effectiveness by objective criteria. Did you design this control in a way that if it operates properly, it actually would secure this thing? And is it actually doing that? And again, we've got through that with all of the controls kind of effective and automated. So then we've been running, we just had our 3rd birthday of X15, so we've been running this stuff in prod for, well, maybe 2.5 years in prod. What have we actually seen in that environment in that time? And the first thing we've seen is that DevSecOps checks actually produce a huge amount of noise. It's all well and good for me to go in and say, we're going to put this in your build system, and every time it throws an alert, it's going to fail your build, and you need to then allow list that thing in order for your build to pass. That causes so much noise that we find developers just start turning it off and tuning it out. So that's something that we're having to manage to tune out that noise so that people actually find the alerts to be meaningful. And yeah, relying on them to do that triage themselves, they tend to just turn stuff off because they say, oh, it was all noise, so we tuned it out. The cost of doing point-in-time assessments has been massively reduced as a result of this, which is great. And as I said, some of these are actually coming through with no findings or reduced findings that validates that this shift-left security actually does fix the security bugs. This time last year, exactly AusCERT last year, we were shipping Unloan and Kit, like the next Monday was the go-live date, and we had a locked-in media event with the CEO of the bank and all the big media in Australia, and they were like, this date cannot shift. You must ship the product on that day. So I was here and I spent the entire conference on the phone trying to get these products through the security sign-off. I literally, the only time I got off the phone was to give my talk, and then I went back. I didn't see anything at AusCERT because we were trying to get these products out the door, and we had these huge stage gates around security. We had to get cybersecurity sign-off that the CEO of the bank wasn't going to make an idiot of himself announcing these products that either weren't ready or weren't secure. we've got away from security being, as one of my colleagues at Red Hat used to call it, the long pole in the schedule. It's no longer the critical path task in the schedule that's blocking these things from going live on the due date. Usually we've done all the security sign-offs and it's marketing or risk or something that's running late. On the SecOps side, we have found some cost trade-offs that when we go to ventures and say, oh, hey, can you just dump all your AWS logs into this S3 bucket and then we'll pull this here and do that there? They're like, yeah, that's going to cost like $1 a minute to run that in the cloud. Can we afford that? There has had to be some trade-offs there. And the incidents that we've actually observed, and Kevin will speak about an incident in a minute, has been really heavily focused on user interaction. That no matter what we build, like I feel like we've done a good job of building DevSecOps and SecOps for these ventures, but you still have the human factor. People click links, people get phished, and that's where all of our actual incidents have taken place. So there's been multiple successful phishing attempts, i.e. they phished the person and got their creds. And then how we wind up catching them is because we have MFA and SSO, and we're fortunate that the nature of our business is that everybody is in Australia, so the conditional access policies block any login attempt outside Australia, and every time somebody gets phished, inevitably the source address of the attacker is in the US or something, and then that's how we catch them trying to, and then the SSO prompt fails, and we get that detection. So yeah, Kevin will quickly run us through an example of an incident, and then we'll go to questions.
It's probably a short one. This is just a Defender alert. This is one of the incidents that we get. This is based on the SOC Girlish campaign. So you typically get like a fake Chrome updater, and the user would click on it, open up the zip file, and click on the JavaScript, right? And luckily this didn't reach the second stage. Otherwise there will be a C2 in there. But we see this, multiple alerts lining up into a single incident, which is nice. And the next one is just a Sentinel view, right? Because we integrate both Defender and Sentinel. So that's one advantage of it. Gives us a single pane of glass, if you like. I hate saying that phrase, but I had to. But yeah, that's pretty much it. Thanks for listening.
So we'll throw to questions if anyone has anything they wanted to ask, or I'm not sure what Billy's going to do.
Hello. There we go. Who had questions?
You were talking about on the SecOps side about log ingress, and you were quite selective of that. And also the cost implications. What steps have you got in place, what guardrails have you got in place that you're not missing things you really want to ingest, having some blind spots in your SIEM functionality? Yeah,
so the way we've done it generally is we identify the attack paths to it, right? And identifying what data sources that we need to actually produce those logs for detection, right? And also considering the prevention controls around that, like how does an attacker even get there, right? So we kind of balance out whether it's something that we surface as an alert or something that we just look on demand to correlate against an alert, right? But we also get, informational alerts that doesn't necessarily pop up in Sentinel. We just set them as security alerts, but it'll send us a notification to say, hey, this happened. It's just for situational awareness purposes.
For the static application security testing, do you have any tips for tuning out those rules?
Yeah, I used to do this Java security stuff for about 7 or 8 years and go around. And I remember there was one, I can't remember the name of it now. There was a Java open source static analysis tool, and I always used to make the quip that it was really good because it had like 10 noise to 1 signal ratio. So it was like the best static analysis. It's still actually the best I've ever seen. For some reason, the name of that tool is eluding me right now. So yeah, the signal to noise ratio is massive. And I think the only thing that you can really effectively do is start to tune out categories, to take entire categories of detection and just say, like, for example, we've done this. We have GraphQL with introspection this isn't a static analysis thing, but on our perimeter, we have GraphQL with introspection by design on a bunch of things. And so we just tune that finding out systematically to say we don't care. Yeah, so that's the only advice I would have, is if you've got to identify bug classes, that you can just say, this is all noise, it doesn't pertain to our environment, and tune it out. Yeah.
Do we have any more questions? Oh, down the back.
Yeah, so now that you've got these pipelines in place, what are your next steps, like onboarding more products or a lot of tuning, that sort of thing?
Yeah, so in terms of products, we're at the mercy of the broader business, what they do, whether they spin up new products, acquire new businesses. That's not really our decision. What we're trying to do now is grow alongside these things. So if we look at Unloan as an example, that's gone from this time last year, I was trying to get the CEO on stage without making a stooge of himself, to now we've got billions of dollars of loans in that, like literally in that business. So a lot of our focus has just been on, oh, okay, now we're actually operating this thing in prod with this real life stakes and this real life oversight from regulators and actual attacks happening, et cetera, et cetera. So that's been a lot of our focus of just how we scale with the businesses. There are a few things. So the two big things that we brought into the environment last year were BugCrowd and Asset Note, and those we then brought into the rest of the bank. The two big things that I'm looking at this year are probably YubiKey or some kind of phish-resistant MFA, and we should really get my messages off the screen, by the way. That's great, OPSEC. And the other one is like an enterprise browser, something that we can use to sandbox third parties that utilize our systems. That's kind of where the future goes for us.
Thanks very much. Great talk. Just wanted to ask a question in terms of, have you thought anywhere about how you might incorporate validation of your detection capability as part of your build process? So the idea of maybe incorporating into your build pipeline attack simulation and then being able to verify that you're able to detect the attacks that you're looking for, the use cases you talked about as part of that build process as well. Sort of like a detection as code approach that's sort of becoming something that's a bit of a hot topic at the moment.
Yep. So our infrastructure as code includes detection as code, and we manage the lifecycle of that detections anyway as code. The challenge that we have now is running those atomic tests automatically in a separate environment, like a sandbox environment, and validating that. Right now, it's just testing whether the template's correct before we merge.
We got time for one more question? No more questions.
All right, well, thank you very much, everyone. Have a lovely day.